Okay, hello everyone. I'm going to take this time to summarize, I don't know whether it's intuition or insight, that in fact the place to start to learn integration and differentiation is at sines and cosines. So here's my premise, okay? You should start calculus with sines and cosines. There's my premise. Now, where does that start? My guess would be that that starts at around 5th grade. And I'm going to build on the work of BetterExplained.com when I start talking about this, but the 5th grade thing comes down to basically looking at the wheels on the bus go round and round type of work here. All right, so let's look at why I believe that. So first off, I believe it for a couple of reasons, but mostly because we have the confluence now of things like Wikipedia, Wolfram Alpha, and Khan Academy. And because we have a lot of wheels on the planet. Discussion of what actually is a sine wave and where it comes from can get pretty intense, but I think the best discussion we have is effectively if you have a wheel going around the circle, around something like this, and if you keep track of a spot of it, if you look at it with your eye from there, you're looking at basically the sine wave, and if you look at it with your eye from there, with this being up, you're looking at the cosine wave. So if you think of right now at this point, the value of it is 1. The value of it in terms of an up and down this way is 0, and the value of it now is 1. When it turns to here, the value is, in this case, it's 1, and in this case, it is 0. When it goes to here, it is from 0, 1, it is back to 0, and here it is what? -1. And when you go back to here, it is -1, and it's back to 0. So what does that look like? As you go around the circle, the sine wave begins here, goes back at pi, or 180, and it's back to there. Bad case. And now I'm going to switch colors on us here, and the cosine looks something like this. It's out of phase, not quite perfect here. So this becomes essentially the cosine wave, and go back to here. This is basically here the sine wave. Now, the reason why I talk about starting calculus sines and cosines is, in fact, if you look at here, you can get the value of the slope of the sine from the cosine, and you can in fact effectively get the value of the slope of the cosine from the sine, though it's a little harder. So you start with these concepts very early. What is the addition, opposite of addition? Subtraction. Of multiplication, it's division. And not too quickly, and before you go into integrals or I'm going to logarithms, you can say the opposite of the slope is the area. But let's just start with the concept of what a derivative is. And at core, it is the slope. And we'll start with this. So what is the derivative of the sine? Well, the derivative of sine, if you look at this, comes up with a slope of 1. It's at 45-degree angle. The derivative of sine is actually the cosine. Derivative of the cosine is a little harder, but if you look at it here, well, that slope is 0. That tells us something, but as you get here, this gets more negative and this gets more positive, and you can see the derivative of the cosine is, or you can use intuition, it's minus sine. Now the opposite of derivative is integral. And the integral is the area underneath. And I think Sal talks about this a fair bit. So what is the integral of cosine? And what is the integral of sine? And of course, typically you'll see it's going to be dx, cosine x dx, sine x dx. And now it's a little weirder, and you can't necessarily make much out of it, but you have to realize you get the integral of the cosine, it's the opposite, you get the sine. And the integral of sine, you get minus cosine. Whereas these are not very intuitive. These are. And you get them by learning to draw the sine and the cosine together at the same place you're learning to draw the unit circle up to 45 degrees, learning to look at what is a sine and a cosine and a tangent on a unit circle. But in effect, by learning to draft these waves for cosine and sine, by looking effectively at a wheel spinning round and round, round and round, and learning to look at this kind of up and down, back and forth, up and down, back and forth, with a wave out of phase by 90 degrees, students should be able to get to the concept of what is a derivative. It is the slope of the curve, and then eventually get to the fact that just by rote or trust that the integral is the opposite of the derivative, but more importantly, the integral is the area underneath. And so if you actually have them look at a curve, you can realize now this area right under here, or in fact under any of these, is actually equal to 2. And we can prove that in another spot. So I'm going to put this out. I think Khalid at betterexplained.com talks a little bit about doing this with money. And I think that is equally relevant. But somehow, something about the wheels on the bus. The wheels on the bus go round and round. Makes me think that the wheel is going to be a better place to start than the bank account. Thanks for listening.